Hello, so in this video we're going to talk through some integration by parts examples. Now if you remember, integration by parts is basically the analog in integration for differentiation when you're doing product rule, okay? So I can say that the integral of u multiplied by dv, so in other words the integral of two functions multiplied together, one of them is u, one of them is derivative of v, that should be equal to u multiplied by v minus the integral of v du. Okay, so nice, simple, snappy thing to remember. Integral of u dv equals uv minus the integral of v du. So in this case, with my example here, I'm going to let that equal u and that thing equal dv. Now, by the way, choice of u, choice of dv, it can be a bit subtle and it comes with experience, but generally you always want to let u equal something that will differentiate down, okay? So for example, I'm letting u equal x in this case, because I know that I need du, which means when I differentiate x, it just becomes 1, okay? Which means that my second integral is a lot easier than what I'm dealing with at the moment, okay? Because of course, dealing with integration by parts is usually because you can't deal with that thing directly. So sure, your formula does have an integral in, but the hope is that that second integral that you end up with in your formula will be a lot easier than the integral that you start with anyway, okay? So let's write that down. So I've got u is equal to x, and I've got dv is equal to 3x plus 1 all raised to the power 5. Okay, so if I differentiate this, so if I find du, derivative of u, that thing should be equal to, well, it should just be equal to 1. Okay, so I'm going to say du is equal to 1. Now, if I want to differentiate, if I want to find v from dv, then I'm going to need to integrate. Looks a bit awkward, but it's not that bad, okay? Just remember, I'm going to have to raise the power by 1, so I'll have 3x plus 1, all raised to the power of 6. I need to divide by that new power, so I'll end up with 6 on the denominator, but I'm also going to have to divide by the derivative of 3x. So in this case, the derivative of 3x is just equal to 3. That's equal to 18. If you weren't sure about how I got that, by the way, you could always just use integration by substitution to work out what the integral of 3x plus 1 all raised to the power 5 is. But hopefully you're happy. It's 1/18 of 3x plus 1 all raised to the power 6. So now I'm in a position that I can actually use my formula. So I'm saying that the integral of this thing, okay, should be equal to u times v first of all. Look at the first part of my formula, my u times v. That's going to be x times by 1/18, so x over 18, times by 3x plus 1 all raised to the power of 6. Okay, so that is just simply going to be u times v. Okay, but then I'm going to need to subtract the integral of v du. So the integral of v du is going to be 1/18 of 3x plus 1 all raised to the power of 6 times by 1, which is my du, and I'm going to integrate that with respect to x. Okay, so that there looks a lot easier than what I started with. Okay, okay, so let's have a look. So I end up with x over 18 times by 3x plus 1 all raised to the power of 6. Take away, okay, integral of this thing. So first of all, raise the power by 1. So I end up with 3x plus 1 all raised to the power of 7. Divide by that new power, but I'm also going to have to divide by the derivative of 3x plus 1. So I end up with 1/21. So 1/18 times by 1/21 of this thing plus c. Okay, so I could, if I wanted to, do a little bit of simplification. For example, the 1/18 times by 1/21 is equal to 1/378. You can argue whether that's any easier or not. 378. And then you could also pull out something like a 3x plus 1 all raised to the power of 6 as an example. But to be honest with you, I'm going to leave it there. So now let's have a look at this one, which is a slightly more interesting example. Let's have a look at the integral of natural log of x with respect to x. Okay. Now this looks a bit weird because it doesn't look like a candidate for integration by parts as it stands, because I'm not multiplying two functions together. But I can do this if I think about this as 1 times by the natural log of x. Okay. So in this case, what I'm going to do is I'm going to think about the facts. I'm going to be careful about what I'm letting u equal and what I'm letting dv equal. Because whatever I let dv equal, I'm going to have to be able to integrate it. So clearly, if I let dv equal natural log of x, then I'll end up with an issue because I can't integrate natural log of x. That's the exact same problem that I've got here. So what I'm going to do instead is I'm going to let u equal natural log of x, and I'm going to let dv equal the 1 times that. Okay, so let me write that down. So I've got u equals the natural log of x which means that the derivative of u, which I need du, that's just going to be 1 over x. And if I let v equal the 1, then that means the derivative of v, okay, so sorry, that's dv equals 1, then that means that v, which is of course my original function before I differentiate it to get 1, should just be equal to, well, it's just going to be equal to v, okay, so it's just going to be equal to x, sorry. Okay, so it's just going to be equal to x. Just simply integrate 1 with respect to x, I get x. So now if I stick this into my formula, well, okay, I get u times v, which is natural log times x, so natural log of x times x, minus the integral of v du. So v is equal to x, du is equal to 1 over x, and I'm differentiating this with respect to x, so this should be equal to x times the natural log of x, minus the integral of x divided by x, that's just 1. So it's exactly the same situation as I had for my dv. So I had dv equals 1, which means v came out as x. Now you can see, hopefully, this is equal to x natural log of x minus this thing here is just x. And of course I add my constant integration. So you might look at this and say, integral of natural log of x? Doesn't exist. But of course it does, and I can do it by integration by parts.